Hi everyone. It has come to my attention that folks have a lot of trouble dealing with the concept of complements and at least one. So let's think about what at least one means. If I were going to buy you at least 1 cup of coffee at the local bean this week, and I bought you 1 cup of coffee, then I've told you the truth. If I buy you 2 cups of coffee, then I have still told you the truth. But if I don't buy you any cups of coffee this week at all, I haven't told you the truth. So at least one means one or more. And the opposite of at least one then is none. So let's look at what that looks like if we are calculating some probabilities. So, for example, not getting at least 1 girl among 3 children is the equivalent of getting no girls. So we have this procedure. The procedure of getting at least 1, we use the symbol A, that's always our event. A with a bar over it is what I use for the complement. That would be getting none. So to calculate the probability that none of the outcomes is being considered, we would subtract from 1. At least 1 is 1 minus the probability of none. This is the most important part. The probability of at least 1 is 1 minus none. Okay, so find the probability of a couple having at least 1 girl among 3 children. Assume that boys and girls are equally likely and that the gender of a child is independent of any other child, meaning they don't have any children yet, and they're going to have a child, have a child, have a child. At least 1 girl. Okay, so that would be 1 minus the probability of no girls. Okay, which means 1 minus the probability of all boys. Okay, births we can think of as being like 50-50. So the probability of a boy would be 1/2. And then we are having 3 children. So it would be 1 minus 1/2 to the 3rd. And you can do this as a fraction or as a decimal. And you can write that as 1/8, or you can write it as, you can write that as 7/8, or you can write it as 0.875. Both of those would be considered valid because you know what 7/8 means, and it's kind of a nice normal fraction, so that would be just fine. But we did 1 minus none, 1 minus no girls. Okay, so let's do a test question. If you make guesses for 5 multiple choice questions with 4 possible answers, like A, B, C, D, what's the probability of getting at least 1 correct? At least 1 correct is the same thing as all wrong. At least 1 correct would be 1 minus the probability that they're all wrong. Okay, so let's think about wrong. If we've got 4 answers, A, B, C, D, and let's just say one of them is right, then 3 of them are wrong. 3/4 are wrong, and we have 5 questions. So we're going to do 1 minus 3/4 to the 5th. I've just got my calculator right here. 1 minus 3/4 raised to the 5th is 0.7626, so that rounds off to 0.763. All right, so I want y'all to try this question. If you make guesses on a true-false test with 5 questions, what's the probability of getting at least one correct? So, I think the video is going to stop at this point and give you a chance to work this question and see how that goes. So, give it a go. Okay, now let's check your answer. At least one correct would be 1 minus the probability that they're all wrong, and these are true, false. One minus the probability that they're all wrong. So 1 minus 1/2 to the 5th would be 0.96875. So that's 969. At least one correct. And so that would be getting 1 correct, or 2 correct, or 3, or 4, or all 5. The only way you don't get at least one correct is if you get all 5 wrong. 1/2, 1/2, 1/2, 1/2, 1/2. Okay, so last question. A couple plans to have 6 children. That's crazy, but it could happen. What's the probability that they will have at least one girl? Okay, so try this question, and then we will check it in just a minute too. Okay, so let's check it. At least one girl would be 1 minus the probability of no girls, which would be all boys. So that would be 1 minus boys, or 1/2, and we have 6 children. 1 minus 1/2 raised to the 6th. So that would be 0.984. So I hope this helps with at least one. Okay.